Hello everyone, my name is Rafael Aylara from BSIT 3-3, and now I'm gonna discuss about simple transposition ciphers using permutation. The permutation cipher is another form of transposition cipher. It's similar to columnar transposition in some ways, in that the columns are written in the same way, including how the keyword is used. However, the permutation cipher acts on blocks of letters, the lengths of the keyword, rather than the whole ciphertext. Mathematically, a permutation is a rule that tells you how to rearrange a set of elements. For example, the permutation shown to the left is how we write a permutation mathematically. Tells us that the first element is moved to the third position, the second element is moved to the first position, and the third element is moved to the second position. As an example, we shall encrypt the plain text "the quick brown fox jumped over the lazy dog" using the keyword bad. We start by creating a grid that has 3 columns, as the keyword has 3 letters. In this grid, we will write out the plain text beneath the keyword. We add a row with the numbers representing the alphabetical order of the letters of the keyword. In this column, plain text, the first row is a bad. It is the keyword. In the second second row, it is the mathematically permutation. In the third and to the last row is the message. After you get the message or the keywords and mathematically permutation, we need to encrypt the message. We use the alphabetically in order to get the ciphertext of the message. And this is the plain text. The first row is the bad, which is the keywords, and the second row is the mathematically permutation. Then we need to, as you can see, under the letter B it's number 2, and under the letter A is number 1, and under the letter D is number 3. To get the ciphertext, we need to arrange the first row into a alphabetically order, and as you can see in the ciphertext, it is arranged in alphabetically order, and the under the letter A is number 1, and under the letter B is number 2, and also under the letter D is number 3, as you can see in the plain text in the first column. In the plain text, the grid filled with the plain text under the keyword bad, which has been labeled. And in the ciphertext, the grid once the columns have been reordered so that the keyword is an alphabetically order. And we then reorder the columns so that the numbers are in order, like in the image to the far right. Then we then read of the ciphertext row by row to get ciphertext. The spaces are included for clarity and would not be included in the final ciphertext. Mathematically, the permutation that has been applied is shown to the right. Then that's all. Have a nice day.
Good day, my name is Crystal Shino Piana, and I am here today to share to you the polyalphabetic cipher, how to encrypt and decrypt. So, a deep information about polyalphabetic cipher. A polyalphabetic cipher is any cipher based on substitution using multiple substitution alphabets. The Vigenère cipher is probably the best known example of polyalphabetic cipher, though it is a simplified special case. The Vigenère cipher was the first of many polyalphabetic cipher which worked in much the same way. The only difference between these related cipher was the way in which the key stream is generated. The Autokey cipher is one such example. In general, the term Autokey refers to any cipher where the key is based on the original plaintext. In its simplest form, it was first described by Girolamo Cardano and consisted of using the plaintext itself as the key stream. However, since there was no key involved in this system, it suffered the same major flaw as the Atbash and the Trithemius cipher. If you knew it had been used, it was trivial to code. So let's jump to the example to encrypt a Autokey cipher in polyalphabetic. So an example encryption. So where we were using a plaintext of word B colony, and the key stream is the word B from the original plaintext B colony. And for the first letter, the B in the plaintext and the B in the key stream in the table from the key stream is we were looking here for the key stream, and this is for the plaintext. So this is the x-axis and this is with the y-axis. So from the x-axis, the B in the key stream and the B in the plaintext, it intersect at letter C. So B and B is equal to C. Next is the B, I mean the E in the plaintext and the E in the key stream. So as in the first procedure, from the x-axis to y-axis, just find the letter, then look for the intersect letter of each two. Is letter I. There is letter I. So the E and D is equal to I. It is also in E because it is the same word. The second word. So for this decryption, we're still using the cipher for the ciphertext is the encrypted text from the previous encryption. So it is CII-PSPPRM, and the key stream is still B. So for the first letter, D of B. From the D is from the ciphertext PSPPRM, and of B is the key stream. So in the table, this is the key stream. We're going to find the key stream here in the x-axis and the ciphertext or the encrypted message here in the y-axis. So D of B, we will find the D in the B. So here's the B in the key stream and B. So at the top of the B of the D is the ciphertext. So the D of B is equal to C. Next is the S of E. So the E is the key stream and the S is the letter from the ciphertext DSPPRM. So we're going to the x-axis, from the x-axis E to the S here in the same row. So here's the S. At the top of that is letter O. So the decrypted word, the letter is O. The remaining letters or the remaining text is also the same as the procedure that we use from the D and S. So just look for the key stream here. Then here is the ciphertext. That's it. So the encrypted message is colony. It is the equal word of TSPPRM, and the ZII is equal to P as we encrypted it a while ago. So that's it. Thank you.